we are going to close this thing out. Last session of the day. My turn finally to get up here and share some of my own lessons and experience with LiveOps. So in particular, one of the topics I'm most passionate about is data, because data is like the lifeblood of a live game. And I think a lot of studios collect a lot of data, don't always use data effectively, and a lot of studios, frankly, don't even collect data in the first place. And so I'm going to talk about, in particular, building the LiveOps data pipeline, because that's really critical to operating a live game. We all know how important LiveOps is. We've spent all day talking about it. I don't need to share with you that the reason why 60% of the games in the top 10 last year were still in the top 10 this year is because they're all using LiveOps. So the building blocks, we've talked about a lot of these topics today. We've talked about live events and messaging and content updates and offers and promotions. I'm going to talk about data, because I think data is the bedrock of a LiveOps strategy. If you don't know what's going on in your game, you're flying blind. You simply can't make the right decisions. And I think a lot of companies mistake LiveOps for analytics or just dashboards. Dashboards are great, don't get me wrong. This is a screenshot from PlayFab. We have real-time dashboarding. When you launch a game and you try something, or you launch an event, or you offer a new item for sale, getting real-time data on how that game is performing is critical. So dashboards are great, but dashboards are just the beginning. Because really, dashboards are basically vanity metrics. They're great in that they tell you when things are going well or going poorly, but they're not necessarily actionable. You can't look at this and say, what do I do? And that's really what we're going to talk about today is going from kind of the vanity metrics to actions. So this is an example where you might have your game, and you have these events, and events feed into things like logins, but so what? Up, down doesn't really help you very much. Take retention reports, right? Retention reports are super important, right? We've heard a lot of people today have talked about their day 1 retentions, day 7 retentions, day 30 retentions. Again, that's a critical measure for knowing how your game is performing. But if your day 7 retention is, let's say, 30%, or rather 15%, or your day 1 retention is, say, 30%, and your friends tell you 50% is a better number, and you're only at 30%, well, what are you going to do to fix that? Who knows, right? So how do we get past that? Well, one key thing is something that Lance was talking about, this sort of lather, rinse, repeat loop of having an idea, trying something out, and measuring, right? That learning loop is at the key of ultimately how you're going to make any changes to your game. So the question then becomes, how can data and data collection support this core learning loop? And it really takes, it takes effort. It takes core data to be able to make these kinds of decisions. So let's imagine this is a hypothetical game in which you are tracking level progression. So in this case, red are players who drop out. So this is an example of a game where you've got a ton of players dropping out at level 1. And you're like, why are my players dropping out at level 1? What's going on here? Well, what you want to ask yourself is, what's the difference between the players who are dropping out at level 1 and the players who are continuing on to be successful? You basically want to go look at all your players, the players you like the most. Who are the best players here, right? Guys who make it all the way to, say, level 50 and beyond. And so what you want to do is you want to be able to ask yourself, taking all the players who make it to level 50, and compare them to the players who dropped out at level 1, and say, going all the way back in time to, let's say, level 0 or that early experience, what's the difference? What's the difference? Are there any factors going back in time that you can look at to predict which player is going to become someone who's going to drop out and a player who's going to stick around for 50 levels? And if you can find the difference going back in time, then you can start to say, well, maybe I can sort of nudge the players who are sort of starting to go off the rails and nudge them to look more like the players who are actually, succeeding and sticking around. So in this case, you might have a hypothesis. Well, looking at that data, maybe the players who stayed around for 50 levels, they earned more achievements, right? This is where having that rich data is valuable, because you can go into your data warehouse and start to mine it and start to ask these kind of what-if scenarios. So what if you have a hypothesis? People who earn achievements early stick around. Players who basically make it all the way through the first 2 levels without any achievements tend to churn. So if that's your hypothesis, then you can start to run experiments. You can say, well, what are some things I can do to try and help players who are not earning achievements earn achievements more readily? And one thing, of course, is you can change the game's configuration. You could make the achievements easier. That's one thing. That's an example of an A/B test you could run. A lot of times, though, changing game configuration is tricky, or you don't want to do it for risk of screwing up the balance. So a lot of people often use things like messaging as a way of changing the game. So you might say, well, in lieu of changing configuration, I want to run a messaging campaign. Any player who gets to level 2 who hasn't yet earned an achievement, I'm going to send them a message saying, hey, here's some advice for earning an achievement, or here's a nudge, or maybe I'll give them a gift or something like this. Something you can do external to the game to try to change their behavior in lieu of changing the core configurations. That's one thing you can do to try to change that. And then, of course, once you've done that, then you need to be able to go in and look at the results. Did that thing I do actually change the results? And that's where cohorting comes in. Then you can go back and say, now that I've made this change, compare the data from, say, 2 weeks ago to the data today. Was there any change in players who got to level 2? Did the percentage go up or down, right? So that's where, if you have enough of that rich data, you can make these kinds of analyses and run these kinds of tests to try to change the behavior in your game. So I want to tell an example of one of the most effective game changes I ever saw from my time when I was at PopCap. And this is not a live game. This was Plants vs. Zombies. And this was an example of a change we made based on qualitative data, not quantitative data. But it's still, in my mind, kind of one of the best examples yet of changing a game to address a concern. So at PopCap, we had this tool we called Burrito. And it was basically, it was like an early version of Slack. It was a message board. And this is an example where we had this problem. And you can't read this, so I'll basically paraphrase. But basically, back then, Plants vs. Zombies was called Lawn of the Dead. And we had this problem. Who's played Plants vs. Zombies here? Everyone? Yeah, okay. So you all know Plants vs. Zombies. You're planting, plants to fight the zombies. And back then, this person was saying they had a problem. This person's wife was playing it, and she'd never played a resource management game before, and she didn't realize the importance of planting sunflowers. So she was jumping straight to pea shooters, planting lots of pea shooters, and she kept dying because she never learned that resource management phase. So we're discussing, how do we teach people resource management? And so people are chiming in suggestions here. For example, what if we have reserved spots on the game board for sunflowers? What if we give extra cash to buy sunflowers? But it turns out, take a careful look. How many of you know Plants vs. Zombies well enough to see what's different about this version than the final version we shipped with? Over here. Sunflowers in the second spot? Nope, close, but that's not quite it. In the back?
Sunflowers cost as much as pea shooters.
Right, okay, he got it. So in the original version of the game, sunflowers and pea shooters both cost 100, so 100 sun powers. And so what would happen is, because they were equal cost, people just plant the pea shooters because, hey, you need weapons, right? So they would get a situation like this one. All pea shooters, no suns, and they would die. So we made a simple little change. So after tons of a discussion analysis, the game designers realized, well, let's change the cost of a sunflower. And that was, by the way, an epic change. That resulted in an entire month or 2 months of rebalancing. The entire game had to rebalance because now suddenly this fundamental change in the economy. But that change ultimately fixed it. By changing sunflowers to cost 50 versus pea shooters at 100, naive novice players were basically paying for buying the very first thing they could afford, which was a sunflower. And they were basically, and it was not until they had basically, the cooldown period was set such that it was not until they'd already planted 3 or 4 sunflowers that they had enough energy that they would be able to plant a sunflower, and while that cooldown meter was still filling for that, they would then get an opportunity to plant a pea shooter, and they would basically plant that. And they basically were taught sort of that way around to plant more sunflowers and pea shooters. And I thought this was brilliant because it's an example where we had a problem in the game that was exposed through data or through experience. And the solution was a sort of very subtle little shift that ultimately solved the problem and made PVZ, the hit it became. So if you're going to have actionable business intelligence, if you're going to be able to make good decisions, you have to have rich data because you don't always know until long after the fact what data you are going to need to have in order to make decisions. And also, a lot of these off-the-shelf analytics products, they'll give you pretty graphs, but they don't necessarily give you the kind of core rich data that you need to query to make these kinds of what-if scenarios, which basically calls for a data warehouse. You basically need a full data warehouse with lots and lots of data in it that you can go and query whenever you need to. And ideally, run experiments and try things out without having to go back to your engineering team to ask for new code to try these experiments out. So the first step in a data pipeline is the ability to capture the raw data. If you don't have the raw data, you have nothing. So I'm going to give you some demos of looking at PlayFab and the tools that we give you, but obviously this is just one example. I'm not saying PlayFab is the perfect solution. There's lots of solutions out there. This is just one example of what a pipeline might look like. So the first step is capturing data. At least in our system, we use JSON objects. JSON objects are great because in our system, at least, it's a single line of code to basically fire off a new event to our system. And then the event comes into our backend, we throw it into a Kinesis pipeline, and then we do a bunch of different things to these events as they come in. One thing we do, I'm actually going to switch to a live demo here. I'm actually going to replicate a demo we did actually back at the Snowflake event using our friends HyperHippo and GuildQuest. And if we bring up here the event stream into analytics, so basically these are live events coming in. And the events come in the system, we have live visualization of events as they fly by. All the events are being captured by Elasticsearch. And Elasticsearch is a search engine that means you can go into back in time and search for individuals anytime we need to. So if you're for example, wondering, look at, just for example, let's say player logins. So we're storing 30 days worth of history here. So we can look, for example, just player login events and see the history over time of how players are logging into the game. And we can open up events and look at the individual JSON objects of these things. But these are events that we're generating automatically as part of backend services. Where it gets much more interesting is when you're actually looking at custom events that the game itself is generating. These are custom events where the game is generating arbitrary information that's unique to that game in particular. So in this game, one of the core things that they were looking at was unlocking zones. So a zone is an island in this game. It's a new area. And so every time a player unlocks a new area, they're generating a custom event. So you can see here, actually you probably can't see here. Let me see if I can zoom in. Whoops. So you can see here, they're capturing zone index. That's basically the index of the island being unlocked. And so this JSON object is having all these fields of data. And in this case, they're able to generate the zone index to know when a zone gets unlocked. So all this data is coming in, it's going to Elasticsearch, you can browse through it here, but the more important thing is all this data is also being fed into a data warehouse. This is great, 30 days of retention of data is nice for quick little lookups, but it's not really great for doing really deep and hardcore SQL queries. So once the data gets into the system, one of the next things we do is we deliver it into a data warehouse. And we're actually using a tool called Snowflake, and they were here earlier today talking about their product. What Snowflake does is it gives us a data warehouse where PlayFab took all the data events from all of our customers and put them all into one giant data warehouse. And then we can take per customer feeds of data, and we can basically publish to each customer their own private slice of data. And then customers can create their own accounts in Snowflake and subscribe to those data feeds. And essentially what they get is, this is actually a demo count just for HyperHippo, but if you look in their databases area here, there's this magical table called PlayFab Shared. And this is basically all the events for this game that just shows up in this table. And I think of it as like a magic table because PlayFab is automatically adding events to this table, which means from the customer perspective, this table just keeps growing over time. And every 2 or 3 minutes, new events are being added to it, and it's all in full SQL, so you can do queries against it, you can link to it, you can join to it, you can copy and export it, and so forth. And so one simple example would be, here's an example of a query. Oh, sorry. One other thing I should point out about this that's really cool is Snowflake has this magical property where Snowflake takes that JSON object, and if you go look at the actual database, just to geek out for a second here. So this is a view of data coming in. If you look at this table, things like entity ID is going to be the ID of the player. Timestamp is going to be TS's timestamp, so when the event happened. But there's this magic field here called P, and P's object type is object. And basically that entire JSON object is being shoved as one big blob of stuff into that P column. And normally with most databases, that wouldn't be very helpful because it would just be a giant string of data in a database, and you can't actually get at individual fields. Normally what would have to happen is if you wanted to be able to do a query on any of those fields in that JSON object, you'd have to basically create a separate column in your database in order to query on it. One of the magical things about Snowflake, though, is they take all those fields of data and they make them available so you can query them directly within that object. So if you look, for example, going back to the game here, if you look at an object like, let's go look at a player login event. Let's go look at player logins. Let's pick this is an arbitrary player login, player login. Query that. pick on one of these things. So note this location object here, right? This isn't we're actually doing this based on IP address, and latitude and longitude, so location.latitude and location.longitude are basically fields in this big blob of text, right? This JSON object blob. What we're able to do though in Snowflake is run a query where we can go in here and right here, this is a basic query which will generate a table called login map. And look what I'm selecting, p::location.latitude. I'm basically saying take that p column, which is just a big object, and then grab the location.latitude field and call that latitude, and then likewise p.location longitude, call that longitude from that magical shared table where the event name is player logged in and the timestamp is basically the last 24 hours. So current day minus 1 gives you the last 24 hours worth of data. So I ran that query earlier today, and if you look at, if I want to go ahead and here and run this field here, this is basically going to get me the last 10 fields from that login table. So you can see here's the last 10 rows, and you can see latitude and longitudes are being stored now in that login table. And what's cool is I can then go into a tool like Tableau, and I can actually go ahead and go into my data source. And you can see here, I'm pulling in basically from that same Snowflake. Tableau can talk straight to Snowflake. So I can go into there, go to that same database, pull in this case, that login map table, and then directly render it straight into a map. So this is actually showing me a map. Every red dot here is where a player logged in the last 24 hours for this game. So that's an example of a pretty cool map based off a table being generated from fields, being pulled out of this master table into PlayFab. So that's a cool little example. For even cooler example of what you can do with this kind of data is, let's say I want to analyze a more interesting question. I want to know, for players, how far into the game do players go before they start spending money? And if you remember from the that event stream I was looking at in PlayFab, go back to your custom data here. Oops. So you remember we had, let's find this, anyway, we had those zone unlock items, right? So zone unlock essentially tells me how far a player is going. So I can imagine going to my SQL worksheet here, and earlier today I ran two queries. I ran a query called this one, create or replace purchasers. So I'm basically going in and I'm creating a new table called purchasers where I'm pulling out the entity ID is basically my player ID, and I'm summing up the order total across all player real money purchase items. So in PlayFab, every time a player spends money, we generate an object called real money purchase. And so this is basically saying, since July 1st, pull out all money purchases, sum up the order totals, and then group it by player. So that's going to give me essentially a table where I'm going to get player IDs and how much money they spent. And then I'm separately going to do another query. And this, by the way, is an object that's generated by PlayFab. But down here, I'm going to do another query, and this time I'm using the zone unlocked object, which is generated custom to this game. And here I'm pulling out max zone index. This is going to say for every player, take every single zone unlock item for that player, take the maximum zone index, and create a new row in this table for that thing. So I'm going to get essentially a list of player IDs and the highest levels reached. And we could actually see what that looks like if we wanted to. We could go in here and say select star from highest levels, limit 10. All right, so here you're seeing, okay, here's a bunch of player IDs and the highest level that player reached. Oops. And then likewise, we could do the same thing if we wanted to see what the purchase table looks like. I think called the purchasers. Yeah, so now we're seeing basically how much money basically these players have spent. And then the final step is to then go into a tool like Tableau and then look at the data source here. And here I'm actually running a custom SQL query in Tableau where I'm basically doing a join now. So I'm basically saying, okay, can you guys see this? Not really. I'm basically pulling out in a table here, I'm pulling out for the player ID, highest level reached, and basically how much money they spent, and I'm joining those two tables together. And once I join them together and I visualize it, I get this graph, which is showing me that, in fact, almost all the money is being spent by players who reach the highest level in the game. So this shows you that you don't get a lot of spend until players get to level 10 or 11, which obviously, if you look at this graph, it tells you, okay, do everything you can to keep players around and engage them so they stick around and get to that kind of later part of the game where the real money spending is happening. So that's an example of a graph generated off of the kind of rich data that you're hopefully generating in your game as you go along. Make sense so far? Yep. So this goes to show you why you need to have basically data warehouse access to these arbitrary events. And what's great what HyperHippo is doing, and I think this is a really good best practice, if you go back for a second and look at the kind of events they're generating a ton of events, a ton of custom events. Player prestige and unique cards and things like tutorial step completed and quest unlocked. That's exactly what you should be doing. You should be taking your game and asking yourself up front, what are the kinds of data I may one day want to be able to query, and make sure you're generating events for those things long before you know you actually need it. Because if you wait till you actually need it, it's too late. You can't start generating data once you're past that point. So you want to generate data early and have it in a system where it's really easy to capture it and store it and archive it long before you're ever going to need to be able to access it. Because the reality is data storage is cheap. And one of the great things about Snowflake, unlike, say, Redshift, is that Snowflake completely splits storage versus compute. In fact, the storage is so cheap that we basically, PlayFab will store for you, essentially for free, all the events you send us. You can send as many custom events as you want, we'll archive them for you, and then when you actually want to be able to go in and start doing your actual queries, all you're paying for is basically us to help kind of set up that data share for you, and then the actual compute time you need. So running a report with Snowflake, you pay by the hour, but the storage is basically separate cost. Whereas in the case of like a Redshift, you've got to have a full-time cluster set up where they combine compute and storage together into one cost. This splits them apart, which is nice. Okay, let's go back to this. So we talked about why exponent data warehouse is important. So with that, I'm actually almost out of time. So let me go ahead and stop there and take questions on this, and we're happy to talk to anyone who wants to talk more about or get advice on setting up kind of an effective data warehouse or data pipeline.
Hi, thanks for the talk. So for the Plants vs. Zombie change that you made for the sun, how did you know that that was like a big thing? Because what in the data pointed to that being a big change specifically?
Yeah, so it's a bad example because we didn't have hard data. This is so early on. This was discovered so early on in the process. We were not yet storing hard data. All we knew was anecdotally. We brought in a ton of play testers. A lot of people came in and played it, and other people came in and played it, but half of them had no problem, and about half of them were thought this was the most frustrating game ever. And we're like, wow, why is it that half the players think this game is phenomenal and have to be ripped away from it, and half the games think it's terrible and are really frustrated and are rage quitting? And if nowadays, of course, we'd be archiving data, and we'd be able to look back at that and see this split. But at the time, this is all done anecdotally. And it was all done through what we called the girlfriend test or the boyfriend test, where we'd bring in friends, and they'd play the games in our offices, and we'd watch them. And what we realized was the players who were rage quitting here or just couldn't get past this first level had never played RTSs before. And the players who got past here no problem had all played RTSs before and understood the importance of building up your economy and your resource generation. And so once we realized that, that's when we started brainstorming, well, how do we teach people? We realized it's because they weren't planting sunflowers. And so then we started researching and asking, well, how do we get them to plant more sunflowers? And that's what led us to this change. But if I imagine a world where we were archiving data or storing data, we probably would need the following data. We'd need to know what level people are getting to before they quit. That would have easily shown us a lot of players are dropping out of level 1 versus continuing past it. We would need to have had data telling us what plants they were planting. Right? So we would have had to say, okay, when we said a lot of players are dropping out at level 1, what's similar about those players versus other players? The data would have showed us the players dropping out at level 1 are not planting any sunflowers. The players who are getting past a point are planting sunflowers. So we would have had to have data events telling us basically what plants are, essentially what's on the game board when they're quitting. That would have given us enough data to figure this out if we were looking at it purely quantitatively versus qualitatively.
Hi. I was wondering when you're going through the data analytics part, are you really thinking a LiveOps manager is going to be writing queries in Snowflake?
Right, so great question. No, I'm not anticipating your typical product manager is writing queries in Snowflake. What we're finding, though, is virtually every customer of ours who has any sort of game at scale has at least one sort of data analyst or data scientist sort of on tap. And what we're finding is those people don't want off-the-shelf solutions for the most part, like a lot of the kind of more simpler data analytics solutions. They want like a data warehouse of raw data. And so at least what we've done is we've made it really easy to get that kind of data into a data warehouse. That doesn't mean you can't also use richer tools. And a lot of richer tools do make it easier to kind of drag and drop your stuff. But even here, you could actually take take Tableau, tie it to Snowflake, and you actually can do a lot of queries by dragging and dropping in a tool like Tableau, as well as writing your own SQL queries.
I have another follow-up question. One of the things definitely for the data analyst part is the data structure is really, really important, but then who is the right person to actually create the data structure? I would say kind of like probably the product manager, but unless they're really schooled in good data structures. I mean, a good example is like, oh, like my purchase event, right? Okay, well, what parameters do you want to put in there? How do you want to instrument it? Do you do it based off like source type entry points? Or do I create a different event for all those cases? Because that has way downstream implications, and you don't want to be dealing with that post-launch.
Right. So two comments there. One is, I think there's an opportunity for, and already we're seeing, specialists and consultants and sort of companies who come in and specialize in helping with data analysis. In fact, we've actually got there's one company out there that enough of our partners are working with that does nothing but helping with data instrumentation of games, that we're about to add them as like a preferred partner to kind of recommend people go talk to this company before they launch their games. Because you're right, how you collect the data up front does matter, and you want to make sure you're getting enough data. But I'll also say that one of the things that's nice about Snowflake is because of that unstructured or semi-structured data, you don't have to, like, it used to be, if you got your schema wrong, you were really screwed, because it was very hard to go back, and then you also ended up with having, like, data from before and after a certain date being hard to match up, and it was really a pain in the ass. Snowflake's making it really easy. As long as you're capturing enough fields, you can kind of later on turn them into whatever schemas you want for analysis, just by creating views across it, and that's really, really helpful. So the risk of getting it wrong, the cost of getting it wrong has definitely come down in price, basically. It's a lot more flexible now. And thank you for your time today.